People. My name is Luis Lopes da Silva, and my work is about the strong decay of hybrid mesons. This work was made in collaboration with Atael Machado and Daniel da Silva. The motivation, the outline of my work is a motivation, the hybrid candidates, the interaction Hamiltonian, the decay amplitude, her results and conclusions. The motivation for this work are the new results of pentaquarks at LHCb that confirmed the existence of these states, and these confirmed the existence of exotic states, and then this is very important for this area. Another motivation is that exotic states are predicted by QCD, but the hybrid mesons are not yet detected. And then works that could improve the search for these states is very important. Resonance with exotic quantum numbers is also a motivation because these resonances cannot be explained cannot be accommodated in the usual meson in usual mesons. Another motivation is the Gluex detector that is looking for hybrid mesons. And finally, we need theoretical descriptions to propose candidates and establish their properties to help in the search for the hybrid states. The candidates I will work is with quantum numbers 1 minus plus. The most promising candidates are P1 1040, sorry, 1400, P1 1600. The properties of these states are here. Here we have the mass and width extracted from PDG and other important experimental results to compare our model. The hybrid quantum numbers are presented as a JPC form. The parity is given by minus 2 LQQ bar plus LG, and charge conjugation as minus 2 LQQ bar plus SQQ bar plus 1. The 1 minus plus hybrid meson can be obtained in two distinct forms, in a excited quark model and excited gluon model. And the quantum numbers for these modes are given here. The interaction Hamiltonian is given by this expression, where we have quark fields and gluon fields given by these expressions, and the term we are interested in is this term, that where the gluon is annihilated and a QQ bar pair is created. The diagram for this process is given here. The interaction Hamiltonian can be written in this form, where we have the operator structure and potential. The potential is given by this expression. The transition matrix from a hybrid state A to a BC state of two usual mesons is given by this expression, and with this we can extract the key amplitude. The initial state is given by this expression, where we have hybrid meson creation operator applied over the vacuum, and in the same way two mesons applied over the vacuum. The hybrid and usual mesons operator are given by these expressions in terms of quark and antiquark and gluon operators. If we apply this commutation relation, we will find 4 terms for the amplitude, and these terms has the following diagrams. The first 2 diagrams does not conserve color, and then we will consider only these 2 diagrams in our calculations. We will write the expressions in this form, where we have the 2 terms, d1 and d2, and these terms are right in terms of the wave functions of hybrid mesons and usual mesons, and the potential. The potential and wave function for this process is given by these expressions. Here we have the potential, which has a flavor, a color, and spin and space parts, and the wave function has the same is given by in the same way. We have a spin wave function, a flavor wave function, a color wave function, and a space wave function. The same is applied for hybrid meson too. The color factor it can be obtained with the color wave functions for the meson and for the hybrid meson, and the potential. And finally, we will find 2/3 for both factors, d1 and d2. Here we have the flavor factor. The flavor potential is a delta function, because we don't have color exchange. And finally, we will find the following factors for the processes we will calculate here. The spin factor could be found with this potential, and where here we have the sigma matrix, and here we have the gluon polarization, which has 3 components. One component plus, minus, and 0. And the factors are are given by these values. The spatial term is given by this expression, where we have um, omega k equal to omega in next slides. The wave function for hybrid mesons and usual mesons is the same, is a Gaussian wave function, and it is given by these expressions. In terms of the gamma function and the momentum. Well, and then we have the channels we will consider. The first is P1 to eta prime plus P. This channel has only excited quark mode. The others are zero. The same happens with the channel P1 to eta plus P and P1 to rho plus P. The other channel we will consider is the P1 to B1 pi, and this channel does not have excited quark mode, and has three components for three results for gluon excited model. L equal to 0, L equal to 1, and L equal to 2. The same happens with pi 1 to f1 plus pi. We have these expressions. The decay rates can be obtained by these expressions, where the momentum is given by this expression, and the energies by this expression. And this is the integration over the solid angle. The parameters we will use are here. The mass of the resonance, pi 1, eta, pi 0, rho, f1, pi 1, 1600, eta prime, pi minus, and b1. And the factors C1 for eta prime, and f1 is given by this expression, these values. Our results for P1 1400 are given here. Here is the parameters we will use to adjust these results. And we compare these results with experimental data. We find the branching ratio for these channels equal to 0.311, and the experimental data is less than 0.8. This is in concordance with experimental results, but The total cross section, the total decay width is 22, and the experimental data has 330. And then we cannot uh, does not concord with experimental results. Here we have a plot of these channels where we have that we considered bit, beta G equal to 0.403, which is here, and then we are at the basically at the top of the curves, and then we cannot describe the total decay width because we are at the top of the curves. Here is the results for the are the results for pi1 1600. Here is the are the parameters we used, and we find the following results. For L equal to 0, we find only GE excited gloom results, and for L equal to 2 in the same way. But for L equal to 1, we find results for all channels. The first two in excited quarks, and the second two in these two in the excited gloom model. Here we have we adjust by this braking ratio, where we have 3.8, and the experimental is equal to 3.82, and then we have the total width near from experimental results in the error bars. Then, as conclusion of this work, we find that the pi1 1400 cannot fit the existing data for the resonance, and then we can discard this as an hybrid meson. The results for pi1 1600 can fit the existing data, and then this could be a good candidate to hybrid meson, for hybrid meson. And then we have a few evidence that P1 1600 is an hybrid meson, but the P1 1400 is not a hybrid meson. And finally, we need more experimental data to distinguish, to have better conclusions about these states. And then thanks for all, and thanks for the organizing committee for giving me opportunity of present my work here.